questions 5 through 7 on the 2015 grade 12 Euclid math contest. In the diagram, CAB is 90 degrees. Point D is on AB and point E is on AC, so that AB is equal to AC is equal to DE. DB is 9, EC is 8. Determine the length of DE. Well, let's start labeling this with the information they gave us. So DB is 9, EC is 8, and anything else we'll have to introduce. So DE, I'll just call that X for now. Now they told me that AB is the same as DE and is also the same as AC. So those guys are also X. And therefore this distance AD would be X minus 9. And in a very similar way, this distance AE would be X minus 8. So I've got everything I need in that Pythagorean relationship. So that means X minus 9 squared plus X minus 8 squared is equal to X squared, the hypotenuse of that right triangle. So we have to do this algebra now. X squared minus 18x plus 81 plus X squared minus 16x plus 64 is equal to X squared. Let's put everything on one side. That would be X squared minus 34x plus 145 is equal to 0. And I think this factors XX 145 is divisible by 5, and when you divide by 5 you get 29. And yeah, that works out great. And if it's negative negative, it will work. There you go. So X is either 5 or 29. Well, looking at this diagram, X obviously has to be greater than 8, right? If you look at this part of the diagram. So that means the only valid root or solution is X equal to 29. And that is what they want, the length of DE, which I had represented as X. So DE is 29. LE has two lists, each consisting of 6 consecutive positive integers. The smallest integer in the first list is A. The smallest integer in the second list is B. A is less than B. She makes a third list, which consists of 36 integers formed by multiplying each number from the first list with each number from the second list. This third list may include some repeated numbers. If the integer 49 appears in the third list, there is no number in the third list that is a multiple of 64, and there is at least one number in the third list that is larger than 75. Determine all possible pairs AB. Okay, so let's make this table A plus 1, A plus 2, and so on, A plus 3, A plus 4, A plus 5. And the other side, this is the horizontal side. The vertical side will be very similar, but it's with B's, B plus 1, B plus 2, and so on. So what they're saying is that when these 6 numbers on the vertical multiplied by the 6 on the horizontal, we get basically 36 numbers, which is what they have said. So just to clarify, these are the numbers on the horizontal part of the diagram, and these are the ones on the vertical. Now, we have to do quite a bit of work for this, so let's do it in a systematic way. So first, let's take this one step at a time. Let's start with the first criteria, which is a 49 has to appear somewhere in the list. Well, 49 can only appear if two numbers multiply together to get 49. The first way to do that, of course, is 7 times 7. Those are the prime factors. Another way to get 49 would be 1 times 49. So that means that somewhere in here there's got to be some 7, and somewhere in here there's got to be a some 7, So when you multiply it, you get a 49. Or somewhere in here there's got to be a 1, and somewhere in here there's got to be a 49. That 1 multiplied together give a 49. Okay? So I think that's pretty straightforward. But we have to figure out where. Okay. So what I'll do is, first let's start with this guy here, the 1 and the 49. That's a little bit easier. This is a key part of the question, that A is less than B. So if A is less than B, obviously my candidate for A is going to be 1. And my candidate for B, well, we'll see. So the 1 is going to go here. And that's the only place where 1 can go. It can't go anywhere here. And I say, well, why? Why can't I put a 1 here? Because if you put 1 there, then this would have to be 0, right? If you put a 1 here, this would have to be 0, -1, -2, -3. And you can't have that because all of these numbers have to be positive. You can't put a 0 or a negative. So based on that criteria, the only place the 1 can go is right here. And then these other guys can be 2 and 3 and 4, 5 and 6, right? That's fine. Now, B has to be something, obviously. This guy B. But what can it be? Well, it could be 49. We could put a 49 there. But the 49 could also go here, it could also go here, and so on, right? So B's got a few choices. B can be anywhere between 44 and 49. So B is going to be between 44 and 49. Now you say, well, how did you get 44? If B plus 5 was 49, if we put the 49 down there, this would be 48, 47, 46, 45, and 44. So B would end up being 44. So that's how. So a little bit of thinking. So basically that means that the AB, the pairs AB that we get are 149, 148, and so on. Right, so you get those 6. Okay, that takes care of this guy. Now let's start talking about this one, where you have the 7 and the 7. All right, so let's get rid of these guys. We don't need those. Let's get rid of the 49. Okay, now let's talk about the 7 and the 7. Again, this is a very important point, that A must be less than B. So if A is less than B, that means I can't put a 7 and a 7 like that, because that means A is equal to B, and that's not allowed. A has to be less than B. So if A is less than B, the only way I can do this is by putting, for example, a 6 here and a 7 here. You see what I mean? It's going to be 1 less. So my range for A is going to be 6. But if I put A plus 5 as 7, then this would, A would be, let's see here, 6, 5, 4, 3, 2. So that means my A can be as small as 2. So currently the 7 goes there, but the 7 can also go here or here or here or here, right? And for each of those we have to figure out what A will be. Okay, I think that's pretty straightforward. Now let's figure out B. The 7 I've put initially here, but the 7 can also go here or here or here or here or here. If the 7 goes, for example, there, then obviously B has an upper limit of 7. But if the 7 went here, this would be 6, 5, 4, 3, and 2. So that means the lower limit is 2. Okay. All right, so from these I can make ordered pairs, and then keep in mind A's got to be less than B. So my ordered pairs will be 2 and 3. These are AB. 2, 4, 2, 5, 2, 6, and 2, 7. And then I've got a few more. 3 being chosen for A would give me 3, 4, 3, 5, 3, 6, 3, 7. And then 4 would give me 4, 5, 4, 6, 4, 7, and then 5, 5, 6, 5, 7, and then 6 would give me just 6, 7. So I think these are the only ones with these ranges. Okay, so I'm pretty much done with this first criteria. This is what I got. I got a whole bunch. But now what I have to do is I have to now look at the next two criteria, because the next two criteria will most likely eliminate a lot of these, because something tells me that the answer will be much less than all these guys. Now the next criteria is that there's no number in the list that is a multiple of 64. So when I choose one of these and put them in, that no number in this entire grid will be 64 or a multiple of 64, like 2 times 64, 3 times 64. Okay. Well, 64, a multiple of that is not allowed. So first let's look at these guys here. All of these have a situation where a is 1. So if a is 1, then that means we're going to have 2, 3, 4, 5, 6. Now 64 obviously is divisible by 2. It's also divisible by 4. So perhaps somewhere here or somewhere here might be a multiple of 64. Okay, now let's look at what b's will be. If we have these guys as our b's, then we will try to see what we can get over on this side. If b, for example, was 44, this guy right here, then we'd have 44, 45, 46, 47, 48, and 49. Well, the 4 and the 48, that combined would give me 192. And 192 is a multiple of 64. It's actually 3 times 64. So as you can see, that's a problem. So we will put a blue box around the problem one. So that's a problem, right? Can't have that. But in a very similar way, you can get the same result, a 4 and a 48, for all these other guys. So for example, for the next one, you have a 45, right, for B? That means this will be 46, this will be 47, this will be 48. So again, this 48 times that 4, you'll have a 192 here, which is 3 times 64. So again, that's going to be a problem because that's not allowed. So that means this one is gone also. And you can do the same kind of thing for all the other guys. So you'll see that all of these have to be eliminated. The only one that sticks around is this one, because if it's a 149, you get a 49 there, 50, 51, and so on. There's no 48. So the 48 that causes the problem doesn't appear. So we keep that one. Okay. So now let's talk about all these guys here. When do these or any of them pose a problem? Well, these numbers are much smaller. There's no 48 type of number, but 64 is 8 times 8. So if we have an 8 and an 8, then that's going to be a problem. Okay, now let's see, how do we get an 8 or an 8? All right, let's take a look. Let's just concentrate on the simple range there that a is between 2 and 6, right? So a is between 2 and 6. When it's 2, we have 3, 4, 5, 6, 7. There's no 8. So it seems like when a is 2, we're okay. But what about when a is 3, 4, 5, 6, 7, 8? Well, we're going to have the 8 there. And similarly, for every other value, we'll have an 8 somewhere in here. So when a is between 3 and 6, we're going to have some 8 appearing. Now let's look at the b's. The b range is between 2 and 7. When b is 2, we have 3, 4, 5, 6, 7. There's no 8. But when b is 3, we'll have 3, 4, 5, 6, 7, 8, and an 8 appears. So again, it looks like when b is between 3 and 7, there's going to be an 8. So the only time we're safe is when a is equal to 2. So the only ones that are safe are these guys right here, when a is 2. All the other ones have to be eliminated because they will eventually create an 8 and an 8. So all these guys are gone. So to recap, we eliminated these top ones because the table will have a 4 times 48, and that's a multiple of 64. We eliminated these guys because the table will have an 8 times 8, which of course is a multiple of 64. It is 64. All right, so we are done with that one. So how many do we have left? We have 149 and then those 2's. All right, so now we're down to 6. Okay, we got one more criteria, and that is this criteria right here, that at least one number in this list is larger than 75. So when we make this table, so how do we figure out if this list will have any number larger than 75? Well, what we can do is figure out what is the max. And if the max is greater than 75, then we're set. So we'll do this one step at a time. When it's 149, that means we have a 1 here and a 49 here. That means the numbers will be 2, 3, 4, 5, 6 here, 50, 51, 52, 53, 54 here. The max number will be 6 times 54, which is 324. Is that greater than 75? Well, sure it is. So that is a good one. We keep that one. All right, now let's go and do the exact same thing for these other 5. For 2, 3, that means A is 2 and B is 3. So 2, 3, 4, 5, 6, 7. 7 here, 3, 4, 5, 6, 7, 8 here. And since those are the numbers, that means the number here, the max number, will be 7 times 8, which is 56. So this was 324, but this is 56, and that is not greater than 75. So that's no good. So I hope you get the hang of this. And in a very similar way, when we have 2 and 4, the max numbers will be 7 and 9. And that number will be 63. So that's also no good. When we have 2 and 5, we will have 5 here, and we will have 6, 7, 8, 9, 10 here. 7 times 10 is 70, and that is also not greater than 75. And 2 and 6 will give me a number 11 here. 7 times 11 is 77. Well, that is greater than 75. And finally, when we have 2 and 7, we have 7 here, and this will be a 12. And 7 times 12 is 84, which is indeed greater than 75. So there we go. Finally, we boil it down to the only remaining ones, which are those 3. So the only pairs A, B after all that hard work is 149, 2, 6, and 2, 7. A circular disk is divided into 36 sectors. A number is written in each sector. When 3 consecutive sectors contain A, B, and C in that order, then B is equal to AC. If the number 2 is placed in one of these sectors and the number 3 is placed in one of the adjacent sectors, as shown, what is the sum of the 36 numbers on the disk? All right, so we have to start exploring what it is that exactly they are talking about, and if we can get some sort of a pattern. So I hope that I can, and I'm not going to do it obviously for all 36. That'd be a little bit more time consuming, but let's just see how far we can get. So the general rule, it seems like, is that anytime you have 3 consecutive numbers, B is equal to AC. like that. So, for example, if this was A and this was B and this was C, and I wanted to figure out what goes in here, I would just use this formula, that C is equal to B over A. Well, B in this case is 3, A is 2, so C is 3 over 2. So let's put that in there, 3 over 2. Okay, let's keep going. Now, if this is being treated as A, this is treated as B, and this is my new C, I have to figure out what goes there. Again, C is B over A. B now is 3 over 2. A is 3. And this is going to be 3 over 6, which is 1/2. So now, this is 1/2. You see, you're getting the hang of it. And same thing, if I want to get this one, it's basically just you're taking this one and dividing by this one, right? B over A. So the next C is 1/2 divided by 3 over 2. If you invert and multiply, you get 2 over 3. So that is 1/3. All right. Same thing, if I want this number, I would have to take this one and divide by that one. So it would be 1/3 divided by 1/2, invert and multiply, and it would be 2 over 3. Like that. Same thing, keep going. This divided by this would be the next one. So it would be 2 over 3 divided by 1/3. If you invert and multiply, you get 2. Let's keep going here. The next one would be 2 divided by 2 over 3. 2 invert and multiply 3 over 2. That is 3. And then keep going, and you get 3 over 2. And as you can see, we're pretty much right back where we started. So that means that there's a pattern here, that the pattern looks like it repeats every 6. Those 6, as you can see, it repeats. And that makes it very easy for us now to figure out the total sum of those 36 numbers. The pattern is 2, 3, 3 over 2, 1/2, 1/3, and 2 over 3. And that repeats itself. It's a 6-digit pattern, and there's 36, so 6 times. So 6 times this whole thing repeats. So all we really have to do is just multiply this by 6. So let's see what I get here. 5 plus 4 over 2, which is 2, and 1. All right. So 6 times 8, and that's 48. And that is the answer. 48 is the sum of those 36 numbers. Determine all values of x for which 0 is less than x squared minus 11 over x plus 1 is less than 7. All right. Well, I'm going to do this question in 2 parts. The first part, I will concentrate on x plus 1 being positive, and the next one is x plus 1 being negative. And of course, x plus 1 cannot equal 0 because that would make it undefined. So x cannot be negative 1. Okay, so let's start with the x plus 1 is greater than 0 part. So for that, the equation stays exactly the same. It doesn't need to be modified in any way. What I really mean by that is that these symbols stay the same. Okay. So what I like to do is, first thing is multiply through by x plus 1 to get rid of any fractions. So it will be 0 on that side, and this will be 7 times x plus 1, so 7x plus 7. And then we take a look at 3 scenarios, right? The first scenario is this inequality, where 0 is less than x squared minus 11. The next scenario is where we have this inequality, that x squared minus 11 is less than 7x plus 7. And then the last one is where we match up those guys. And that would mean that 0 is less than 7x plus 7. So that's about as complete as you can possibly be. So from the first one, you get pretty straightforward that x squared has got to be greater than 11. So that means x has to be greater than root 11, or x has to be less than minus root 11. So what I'm going to do, make things nice, is put this on a number line. And when you put it on a number line, it makes it a little bit clearer, I think. So here we got 0, and let's see here, root 11 is what? A little bit more than 3, right? So it's approximately here, root 11 minus root 11. So based on this, we have a scenario as follows, that initially we have either here or here, right? It keeps on going from these. Okay. Now let's go to this one. This one is pretty straightforward, I think. We have minus 7 is less than 7x, divide through by 7, so x has got to be greater than negative 1. Okay, so negative 1 is approximately here, let's say, negative 1. So x has to be greater than negative 1, so it's got to be in this range. And in the end, what we have to do is we have to see what is common to all three ranges. Okay, now finally we got this one. And that one, we'll put everything on one side. X squared minus 7x minus 18 is less than 0. Factor this. And when you do, you get x 9 and 2, I believe, and then negative and positive. So what that really means is if you were to, for example, draw it as a parabola, and it has roots 9 and negative 2, we want it to be 0, less than 0. So that means we want the values of x when the graph is below the x-axis, right? So that obviously means that it's between negative 2 and 9. Okay, so here's negative 2 approximately. 9 is somewhere out here. So that range will be from negative 2 to 9. Okay, so now what you have to do is see on that number line what is common to all three. And if you look at it closely, what's common is this region right here. And that region is that x is less than 9, but it's greater than positive root 11. So that is the first range. And a lot of students might just end there and move on, but this has to be explored as well. And that's an important aspect of this question that some students may miss. Okay, so now that you're an expert, this part may not be as difficult. When x plus 1 is less than 0, then this equation changes slightly. Basically, the signs flip. So it becomes like this. Instead of a less than, it becomes greater than. X squared minus 11 over x plus 1 greater than 7, like that. Okay? Now the rest is exactly the same as what I did over here. So we have, well, first actually, let's multiply through by x plus 1. And we get x minus 1, 7x plus 1. Okay, now we can do exactly what we did before. The first one, that inequality. The second one, x squared minus 11 is greater than 7x plus 7. And then, of course, the last one, that 0 is greater than 7x plus 7. Okay, let's take it again as we did before. So that means x squared is less than 11. So x squared is going to be, well, if you take the square root, x will basically be less than root 11 and greater than negative root 11. So as before, it's always nice to put this on a number line. Makes it a little bit easier to understand. So if this is 0, again, root 11 here, negative root 11 here. And our first sort of range is in between those two. Okay, now let's move forward to the next one. Let's do this one. That's pretty straightforward. So that means minus 7 is greater than 7x. So So that means dividing through, we get x is less than negative 1. Okay, so if this is negative 1 approximately, x is less than negative 1. So that would mean right here, all of that. And then finally we get this inequality. Put everything on one side, we get x squared minus 7x minus 18 is greater than 0. Factoring, we get, let's see here, x, 9, and 2, just as before, minus and plus. So again, same kind of story. If you had a parabola and the roots were 9 and negative 2, we're interested in the region where the graph is above. So it would be from there to there, the values. And as you can clearly see, that's when x is greater than 9, so over on that side, but less than negative 2, so over on this side. So on the number line, it would be those values and less than negative 2, so these values. Okay, so now we have to look at this and say, what is common to all three? And when you look at this carefully, you see the only thing that's common to all three is this region, that small region right there. And that small region is that x is less than negative 2, but is greater than negative root 11. And that completes the question. In the diagram, ACDF is a rectangle with AC equal to 200 and CD equal to 50. Also, triangle FBD and triangle AEC are congruent triangles which are right-angled at B and E respectively. What is the area of the shaded region? Well, I'd like to do a little bit of diagram analysis without going straight into mathematics and algebra. Because if you do that, you'll find that the question can be a little bit easier. So the first thing we will do is we will draw a line straight across like this, and that cuts that shaded region into half. And now let's concentrate solely on just this triangle right here, that right triangle. Now that right triangle is interesting because it can be cut up into components. So for example, if I draw a line from top to bottom like that, and then I draw a line from top to bottom like this, and then one more line from top to bottom like this, and we will see how this behaves. Now let's label these. I will call this region B, that B, this C, and then this top and bottom, so this guy right here, this whole thing, I will call A, and similarly, that one is also A. Okay? So, first, let's talk about what is the big one. FBD, triangle FBD, in terms of my labeling. Well, it looks like it's 2A plus 2B plus 2C, right? Okay, now let's talk about the area of the shaded region. I'll just call it AS for area of the shaded region. Well, that is 2A based on my labeling, correct? Now, let's take a look at the fact of what is A in terms of B and C. I hope you can see that A is equal to B plus C. Because in this rectangle, when you draw a line, this part is equal to that part, right? So if that part is C, then that means the other part is C. So that part is C. Similarly, in this rectangle, when you draw a line to cut it in half, if one side is B, then the other side's got to be B. So that's B, that's C, but B plus C is A, according to my labeling. So that means I can substitute that into here and here, and that will help me out a lot. So first let's do it for triangle FBD, that A is equal to B plus C. So when you substitute it in, you get 2b plus 2c, and then we have 2b plus 2c. And that becomes 4b plus 4c. When you substitute it there, the area of the shaded region is 2b plus 2c. Well, that looks very similar. Basically, it looks like that the area of FBD is equal to 2 times the area of the shaded region. All right, well, the area of FBD I can easily figure out. They gave me the dimensions. They told me that AC is 200, so that means this side is 200 since that's a rectangle, and CD is 50. So here we go. Area is going to be 1/2 base times height. Well, the base is 200 of that triangle. The height, top to bottom, is 50. So 50 goes here. And that is 2 times the area of the shaded region. So area of the shaded region, if you calculate this and divide through by this 2, you get 2500. And that's it. And I'm sure there's other ways of doing this question, but I like that method. It's pretty straightforward. The numbers A1, A2, A3, ... form an arithmetic sequence with A1 not equal to A2. The three numbers A1, A2, A6 form a geometric sequence in that order. Determine all possible positive integers k for which the three numbers A1, A4, and AK also form a geometric sequence in that order. All right, so we have A1, A2, A3, and so on, right? And we're going up to A6. Now, it's an arithmetic sequence, so that means they are of the form A plus D, A plus 2D, and so on, A plus 3D, A plus 4D, A plus 5D, right? And they have told me in this question that A1, A2, and A6 also make a geometric sequence. So A1, A2, and A6, which according to what I just wrote are A plus D, and A plus 5D, these also make a geometric sequence. And the geometric sequence is of the form AR squared. So that's basically the setup of the question. And then later, they tell me that these three guys, A1, A4, and AK, which would basically be, in terms of the arithmetic sequence format, A plus 3D, and A plus K minus 1D, right? Those also, according to the question, form a geometric sequence. So those will also be some different probably ratio, and AR squared. All right? So that's basically just the initial setup of the question. Now we have to do the actual mathematics. Okay. So the mathematics involved is as follows. First, we'll take a look at these guys, which I will call scenario 1. And then, of course, we can take a look at these guys, which is scenario 2. Okay. So scenario 1. What do we know about arithmetic and geometric sequences? Well, we know one thing, that when you take the second one and divide by the first, it's equal to R, because the A's cancel. And the same thing happens when you take this third and divide by the second. AR's cancel and you're left with R. So we're going to do that with these guys. So that means the second one, which is A plus D, divided by the first one, is going to be the same as the third one, which is A plus 5D, divided by the second one. All right? Okay, cross multiply A squared, A plus D times A plus D. So let's just do that math. 2AD plus D squared. And then cross multiply the other guy and you get A squared plus 5AD. Let's see, the A squared cancel on both sides and we get D squared is equal to 3AD. Dividing through by D, you get D is equal to 3A. All right, so that's a very good finding, a very important finding. Okay, I think we're ready for analysis of the second group. Yeah, all right, second group. Same story. No, we're going to do the same thing that we use this aspect of geometric sequences, that second one divided by the first one, and so on, right? So the second one, in this case, is a plus 3d divided by the first one is equal to the third one, which is a plus k minus 1d divided by the second one, a plus 3d. Okay, so now we will utilize this very important finding. Let's substitute. Wherever there's a d, put in 3a. So a plus 3d, so 3 times 3a, all over a. And then here we have a plus k minus 1d, but d is 3a. And here we have a plus 3 times d, which is 3a. Okay. And let's see here that if I cross multiply, actually, let's see here, 3 times 3 is 9, 9 plus 1 is 10. So that's going to be 10a. I don't think I even need to cross multiply. And this part will be a plus k minus 1, 3a, and this becomes 10a. Okay, well, the good news is that the a's cancel. On that side, you just get 10. And on this side, the a's also cancel, and I'm left with 1 plus k minus 1 times 3 over 10. All right, great. Now I cross multiply, and I get 100 is equal to 1 plus, let's expand that, 3k minus 3. So that's going to be 100 minus 199 plus 3, 102 is equal to 3k, and dividing through by 3, k is going to be 34. Man, that's it. That's what they wanted, right? Determine all possible integers k. Well, the only value is 34, and I hate it when they put this all, because that makes you think that there must be so many more. But in this case, there's only one possible value of k, and that value is 34.